Hello and welcome back to math class. You will notice that we are going to move on to lesson 14 today. We're going to continue doing some ratio tables. We were introduced to equations last week, so we're going to kind of look at those some more. We're also going to actually make a double number line diagram today because it's pretty simple. And we're going to plot some points on a coordinate plane. So lots of tasks that we're going to do today. So let's go ahead and get started. All right, so it says, Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown, West Virginia for a tournament. The distance between Yonkers and Morgantown is 400 miles. The total trip will take 8 hours. That's important here. And this here. The train schedule is provided below. All right, so we can see once Kelly leaves Yonkers, you can see the distance, 100 miles. We get to Allentown, 200 miles. Carlisle, 300 miles. Berkeley Springs, and then 400 miles Morgantown. So here is the itinerary for leaving Yonkers, and then here is going from Morgantown back home. Now, the trip will take 8 hours. So that means from here to here is 8 hours. Well, if you notice, we kind of have 1, 2, 3, 4. So to me, it would be 2, 4 hours, 6 hours, and 8 hours. Okay, makes sense. We're going to go down here and make a table. Create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. Well, we notice up here they're all 100 miles apart. Then extend the table to include the cumulative time it will take to reach each destination on the ride home. All right, so in order for us to get to the first place, we have here Allentown. It says that we're going to go 100 miles. So miles over here, so we'll put 100 over here. And we figured that would be in 2 hours. Okay, so the next destination would be 200 miles. And that's 4 hours. 300 miles, 6 hours. And 400 miles to get all the way to Morgantown would be a total of 8 hours. So you can kind of see our pattern. Our hours are counting by twos, and our miles are counting by hundreds. So let's go ahead and continue with that pattern. So in 10 hours, we have 500 miles. 12 hours, we've gone 600 miles. 14 hours, we've gone 800 miles. And 16 hours, we've gone, this should be 700. Now we've gone 800. All right, there we go. All right, so now we're going to go ahead and flip over to the next page. So today we're going to create a double line diagram to show the time it will take Kelly and her team to travel from Yonkers to reach to each town listed in the schedule. Then extend the double number line diagram to include the cumulative time it will take to reach each destination on the ride home. Represent the ratio of the distance traveled on the round trip to the amount of time taken with an equation. So what we're going to do is we're going to take the information that we just did here on the front table, and we're going to go ahead and we're going to label this hours on top, and we'll label this miles on bottom. Obviously, if they've gone 0 hours, they've gone 0 miles. Now, the table that we just filled in, we found out for 2 hours, we went 100 miles. 4 hours, 200 miles. And remember, we counted by twos the whole way. And then we counted by hundreds. Now, where are we getting this information? We're getting this information from the table we just did right there. Okay, so let's go ahead and finish filling it in. Okay, so we have what we would call a double line diagram. Our hours are on the top and our miles are on the bottom. We can match them up by saying in 2 hours, 100 miles. In 12 hours, 600 miles. 8 hours, 400 miles. This is the same information that we had on the table in the front. Using the information from the double number line diagram, how many miles would be traveled in 1 hour? Well, if I notice here, here's 2, so 1 would be in between. And because 1 would be halfway in between 0 and 2, that means we'd probably say halfway in between 0 and 100 would be 15. So we'll write here 15. How do you know? Well, if the train is moving at a constant speed, half of 2 hours is 1 hour. All right, so if the train is moving at a constant speed, that means that the train is going at the same speed the whole time. It's not slowing up or going faster. It's going at the same constant speed. Half of 2 hours is 1, and half of 100 miles is 50. All right, let's move down to example 1. It says dinner service starts once the train is 250 miles away from Yonkers. What is the minimum time the players will have to wait before they can have their meal? All right, so we're going to take the information that we've used up here already before, and we're going to add it to our table here. We already know that in 2 hours, we go 100 miles, and we know that in 4 hours, we go 200 miles. Where are we getting this information? From right up here. Okay, 6 hours, 300 miles, 8, 400 miles, 10, 500 miles, and I'm not quite sure why they didn't extend it. So let's just go ahead and extend it ourselves. Let's extend it down here, and we'll go ahead and extend this down like this, because we do actually go all the way to 16, so we'll do 12, 600, and 14 was 700, and 16 was 800. Oops. Okay. So once again, all of this information is the information from the top of the page up here in our double line. All right, so we're going to talk about ordered pairs and plotting points. So our ordered pair is going to be the two numbers that we see here together, and we'll list them in order. So we would put 2, 100. Okay, we would do the same thing here. We would say 4, 200. It's important to make sure we get that comma in between those two numbers so that we can specify the difference between them. Okay, so go ahead and finish our pattern. The other thing we have to remember is because we're making ordered pairs, we put them in parentheses. So make sure you have parentheses. Okay. So we're going to take this information that we just made in this table, and we're going to plot some points on this coordinate grid. Now, when we look at a coordinate grid, we know that we have here our x-axis and our y-axis. Our x-axis, let's try that again. Our x-axis is usually considered labeled time. And so if we look over here, the time that we're doing is hours. So let's go ahead and let's make sure we don't put it too close to the line. Let's write hours down here, because we're going to need to put some numbers. And then we usually put our distance on the side, and the distance that we're doing is miles. So I'm going to turn my book and I'm going to put miles, but I'm going to make sure I don't put it next to my grid so I can count. And then the other thing we have to do is give our coordinate plane here a title. So I'm going to say time and distance of travel. Okay, now we know that this is our x-axis and this is our y and this is 0, but we need to be able to count. Well, if you notice with our hours, we kind of counted by 2s, and so I'd like to do that down here as well. Since our grid is so small, I'm probably going to kind of skip things. So for example, I would say that this is a 1, the first line, and then I'm going to do 2. Skip 4, 5, 6, 8, 10, 12, 14, 16, and 20. So I kind of skip counted here. I did 2, 3, 4, 6, 8, 10, 12, 14, 16, and I need to make this an 18. Boy, I'm having some issues here. And then 20. Okay? Very tiny line, so it's kind of hard to write here. Now we're going to do our miles. And our miles, we're counting by hundreds. I'm probably going to skip as well, so I probably would skip here and do 100, 200, skip, 300, all right, 200, 300, 400, 500, 600. Okay, so we have to have our pattern, and my pattern over here is counting by 100s, but I wanted to skip lines to make it a little bit easier since the graph that they've given us is so small. So now what we're going to do is we're going to try and plot some points. And our first point here says 2 hours, 100 miles. So we're going to start here in the corner here at our origin, and we're going to go over to the 2 hours, and we're going to go up to the 100 miles, and we're going to put a dot. Okay, now we're going to go 4 hours, 200 miles. So we're going to start here again, 4 hours, and we're going to go from 4 hours up to 200 miles. Go over 6 hours and up 300 miles. Over 8 hours and up to the 400 here. There we go. So we have 100, 200, 300, 400. Let's see if we can get another one on here. Over 10 hours, up 500. Over 10 and up 500. So let's go ahead and just stop there for a second. Okay, so we can see we kind of have a pattern here with our points that we're plotting. And if you were listening, the question actually said, what is the minimum time the players will have to wait before they can have their meal? And it says here, dinner service starts once the train is 250 miles. So if I look here, 250 is going to be between my 200 and 300. And so as I connect these, if I would come between here, 250 miles, and go straight across, it looks like I'm going to hit here at about 5 hours. So my answer would be 5 hours. So we're going to say here, the minimum time is 5 hours. Now, as you can see, it's very difficult sometimes to plot these points on these tiny graphs. So sometimes if you can get a graph or coordinate grid that's a little bit larger, it becomes a little bit easier. All right, so let's go ahead and turn our books over. And I want to practice one more time with you on this problem set. Let's go ahead and look and see what it says. It says, complete the table of values to find the following. find the number of cups of sugar needed if for each pie Carrie makes, she has to use 3 cups of sugar. All right, well, it says that she has to use 3 cups of sugar for each pie. So we're going to go ahead and continue our pattern. So 3 cups of sugar for 1 pie. So then I would have 6, 9, 4 pies gets 12, 5 gets 15. So I'm counting by 3s, as you can see, going down. Okay, and it looks like from here to here, I'm multiplying by 3 that way. Okay, use a graph to represent the relationship. So we're going to try graphing one more time. We have to put our labels. We're going to label down here number of pies. So we're going to put it down here so we're far away. So this is our label, and then our other label will be cups of sugar. So I'm going to turn my book sideways and write here cups of sugar. Okay, and as you notice, number of pies, we're going to be counting by 1s, and by cups of sugar, we're going to be counting by 3s. All right, so if you notice my number of pies, I kind of skipped lines to make it a little bit easier for graphing. So I started here with 1, and then I skipped a line 2, skipped a line 3, skipped a line 4, and I went all the way up to 7, even though our table goes to 6. Okay, now we're going to number our cups of sugar. All right, so what I did is obviously I'm counting by 3s, but I actually counted each line. So for example, I have here 1, 2, and then I labeled 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And you can kind of see I kind of put slash marks on here to help me keep things straight as I'm trying to number this would be my y-axis. All right, so if you notice, we have everything almost complete, except for we forgot something. We forgot to put our title on the top. So let's go ahead and say cups of sugar in pies. Okay, and now we're going to try and plot our points. So in 1 pie, we have 3 cups of sugar. So here's our pies. 1 pie, 3 cups of sugar. 2 pies, 6 cups of sugar. 3 pies has to go all the way up to my 9 cups of sugar. 4 pies, so I'm going to have to stay on the line here until I get up to 12. Okay, so then we have 5 pies, 15 cups of sugar. Here's my 5. Trace up my line here till I get to my 15. And then 6 pies, follow it up until I get to my 18. So your graph should look something like this. Okay, we now can see from the number of pies are listed here on the bottom. We can see how many cups of sugar each pie needs, and we've plotted our points on our coordinate grid. All right, so you're going to have a Google form to practice today. Please make sure you reach out and ask any questions if you are confused.